Hello everyone, I'm Yazan Ibrahim, or as some of you might know me, Yazan Abu Ghosh. Today we're going to dive into a fascinating and essential topic, Information Systems Operations and Business Continuity Management, 26%, concerned with ensuring continuity of services and secure operations. From Chapter 4, Part A, Information Systems Operations 4.1, Common Technology Components. If you are a seasoned auditor or just curious to understand how information systems into business environments, you've come to the right place. Let's begin. Imagine stepping into a world where every beep, click, and whir of the machines around you is the pulse of an invisible network holding our lives together. From the towering mainframe humbling us with its sheer power to the sleek smartphone nestled in our palms, it's all connected by technology's intricate threads. But how did we get here, and what are the pieces driving this extraordinary web? Let's dive into the essential components of modern technology, tracing the evolution of computers, the ecosystem supporting them, and the safeguards ensuring their seamless operation. It's not just machines. It's a dynamic relationship of hardware, innovation, and ingenuity that powers everything from our daily emails to breakthroughs in medicine and science. Section 1, Unveiling Computers, the Heart of Technology. Before we unravel the details of the systems we interact with, imagine the central conductor of an orchestra, the CPU, or Central Processing Unit. This ingenious chip, sometimes just the size of your fingernail, orchestrates thousands, even millions of operations every second. The CPU is a marvel with its three primary responsibilities: performing mathematical and logical operations through the arithmetic logic unit, ALU, dictating the flow of data and instructions like an efficient manager, that's the control unit, holding bits of data momentarily in its internal memory, the CPU registers, essentially a tiny but blazing fast workspace. But a great conductor is nothing without the orchestra. The CPU collaborates with other hardware components. The motherboard, the sprawling highway of connections, enabling communication between all the internal components. RAM, or random access memory, which provides short-term memory to keep work in progress readily accessible. Then there's storage. Picture two approaches. The hard disk drive, HDD, is like sifting through file cabinets, efficient but sometimes slow since it's mechanical, with literal spinning disks and read-write heads. Meanwhile, the solid-state drive, SSD, replaces moving parts with solid-state memory, a significantly faster and more energy-efficient approach. Even powering these processes gets its own dedicated hero, the power supply unit, ensuring electricity flows safely to every little chip and circuit. Section 2, From Input to Output, Technology Encircling Us. When you interact with a computer, it's a dance between inputs and outputs. Take the classic click-clack of a keyboard, the quintessential input device, feeding commands into the machine paired with a mouse or touchpad. On the other side, output devices like printers transform binary commands into physical creations, while monitors bring pixels to life in vivid displays of color. But let's not forget the hybrids, like touchscreens that break the mold, simultaneously serving as both input and output. Section 3, The Great Divide. Types of computers. Pause for a moment and consider the staggering variety of computers. They may share core components, yet their purpose and power set them apart dramatically. 1. Supercomputers push the boundaries of performance, solving problems that otherwise would take decades. Think weather predictions or mapping the human genome. 2. Mainframes follow as hulking behemoths that run hundreds of programs simultaneously, efficiently serving thousands of users across the globe. 3. Mid-range servers, often high-end in capability, generously trade some of that sheer scale for versatility, running everything from databases to file storage. Then there's the world of personal computing. Desktops, which established the vision of a computer in every home. Laptops, which broke that vision free from fixed spots, empowering us to work whenever and wherever. And in our palms, smartphones and tablets, redefining portability while merging computing, communication, and entertainment. Even ultra-specialized computers like thin clients minimize hardware needs, relying on servers to handle much of the workload. Behind them all, power and innovation spark endless possibilities. Section 4. Enterprise Backend Devices, the Unsung Heroes. Behind every online purchase or company database lies a bustling network of specialized servers. File servers, those central libraries that house essential data. Application servers, multitasking hubs that make software run smoothly for all users. Web servers, your guides through the labyrinth of the internet, serving web pages and handling your countless searches every day. Even simpler devices like print servers consolidate and optimize printing for businesses. And who could forget the sleek and strategic proxy servers, intermediaries that secure and speed up our online connectivity? Complementing these servers are dedicated network appliances. Imagine a backstage crew protecting and optimizing performances, firewalls for security, load balancers for keeping everything running smoothly, and virtual private networks, VPNs, for safe encrypted pathways through public networks. The dazzling complexity of these back-end devices enables the seamless systems we often take for granted. Section 5, Small yet Vital Universal Serial Bus, USB. Let's zoom in on a seemingly humble yet revolutionary innovation, the USB. By standardizing connections between devices, USB eliminated the chaos of needing countless cables for every new gadget. A USB flash drive, another marvel, lets you carry gigabytes or even terabytes of data tucked away in your pocket. But these small wonders have their flaws. The portability of a USB makes it easy prey for theft, data leakage, and malware. Without encryption or robust policies, the risks scale quickly, whether it's losing sensitive client data or introducing a virus to a secure system. Section 6. From RFID to tomorrow's innovations. Speaking of small but mighty, let's shift to radio frequency identification, RFID. Ever walked out of a store and heard alarms blare because someone forgot to deactivate a tag on your purchase? That's RFID in action, a mix of a microchip and radio waves tracking products, streamlining inventory, or even granting access to buildings. While RFID simplifies logistics, security concerns loom. Unauthorized tracking or hacking into RFID systems can jeopardize privacy or business data. Without robust technical and operational safeguards, these efficient systems can become vulnerabilities. Section 7. Maintenance. Keeping the machine oiled. Finally, we cannot overlook maintenance. Every intricate system from massive data centers to desktop PCs relies on rigorous upkeep. Whether it's cleaning fans, replenishing thermal paste, or adhering to environmental standards, routine care prevents failure and prolongs the life of technology. Monitoring tools help track availability and usage, ensuring systems operate at optimal efficiency. Through dashboards and error reports, administrators anticipate bottlenecks or breakdowns, addressing them before users even notice. We've traveled across decades of innovation, exploring the intricate and fascinating world of technology hardware. The machines we use every day, whether desktops, smartphones, or supercomputers, aren't just objects. They're testaments to human ingenuity and vision. The next time you look at your phone or sit at your computer, take a moment to appreciate the vast ecosystem of hardware, innovation, and care powering your digital world. It's a story still being written, driven by human curiosity and the relentless pursuit of progress. Thank you for watching, and as always, continue learning. Stay curious, and we'll see you next video.